In this video, we'll discuss the distinction between proportional and inversely proportional relationships. Now, if you remember, a proportional relationship is one in which one quantity is multiplied by some factor, so the other quantity is multiplied by that same factor. In an inversely proportional relationship, as one quantity is multiplied by a factor, the other quantity is divided by that exact same factor. We see this in many different situations, especially when we think about job completion, when we can increase or decrease the number of people working on a job. For example, if I have 2 people taking 12 hours to fill up a truck, and I want to know, well, how much faster could we do it if we put 6 people in that same job? So we can create a table to help us think about this. So I can look at the number of people and the number of hours. Originally, I have 2 people taking 12 hours. But now I'm going to increase that to 6 people. And I say, well, what's that relationship from 2 to 6 as a multiple? I'm multiplying by 3 here. Since this is inversely related because it should take me less time to complete this job, I'll divide by 3. So that will give me 4 hours. So the point is that since I have 3 times as many people working, it will take me a third of the same amount of time. Thus, 6 people should be able to complete that same job in 4 hours. Let's look at another example. Say a computer company programs 2 computers to sort incoming orders. It takes those 2 computers 24 minutes to process 1,000 orders. If they add a third computer, they want to know how quickly can they now process those same 1,000 orders. So if we think about the number of computers to the processing time, we had 2 originally taking 24 minutes. Now we're going to go up to 3 computers. And we say, well, what's the multiplier to go from 2 to 3? I'm not adding, I'm multiplying. And that would be 1.5 times, or 3 halves. That means I'm going to divide by 3 halves. And when I divide by 3 halves, that's the same as multiplying by 2/3. So 2/3 of 24 is 16 minutes. So 3 computers should be able to complete the same job in 16 minutes. Now sometimes we may have to go and use both types of proportional relationships to help us solve a problem. This is often multiple steps and you can go different ways. Just take one proportional relationship at a time. For example, a manufacturing company knows that its 8 factory lines can produce 50 tablets in 20 minutes. However, the company gets an order for 6,000 tablets when 2 of its factory lines break down. How long will it take the remaining 6 factory lines to complete the order? Here we have 2 different things occurring, and that's important to relate as we're trying to solve this problem. We have the number of lines, we have the number of tablets, and we have the number of minutes. All of these have to have a relationship. In the beginning, we know that there are 8 lines producing 50 tablets in 20 minutes. In the end, we know that we need 6 lines producing 6,000 tablets, and we don't know how long that will take. So we need an intermediary step to help us solve this problem. So the first thing I would do is I'd say we got to deal with one issue at a time. I say, what happens if I didn't lose those 2 lines? Say instead, I'd think about what happens if there were all 8 lines available. So that would be 8 lines to do 6,000 tablets, and I want to know how many minutes that'll take. That now, because I haven't changed the number of lines, will become a proportional relationship. I'm looking and saying, how do I go from 50 to 6,000 and proportionally from 20 to some other amount of minutes? I can set up that proportion, I can cross multiply, divide, and simplify that so that I would find that it would take 2,400 minutes to create the 6,000 tablets if all 8 lines were working. That's step 1. But now that I know how long it would take with all fully working, I can look at what happens when I decrease the number of lines. So here, I'm going to be decreasing it from 8 to 6. And what's going to happen? That's what I want to think about. Now, that is going to be an inverse proportional relationship, because by decreasing the number of factory lines, I know that the time it takes to create the tablets has to go up. They're going the opposite directions. That's the inversely proportional relationship. So how do I multiply to go from 8 to 6? I multiply by 3/4. That means I'm going to then divide 2400 by 3/4. So I'm looking at 2400 minutes divided by 3/4. If you remember though, we don't divide by fractions, we multiply by their reciprocal. So really I'm looking at 2400 minutes times 4/3, or 1 1/3 times. When I do that, I'll end up with 3200 minutes. That means that it will take 6 factory lines 3200 minutes to complete the production of all 6,000 tablets.